Thank you. Thank you. Welcome back to the second part of the evening. We have two surprises. Surprise one, I'm doing the announcement. Surprise two. Zachary, Ruby MI and C Ruby co-winner, right? And he will have a surprise talk for you. I guess it's something to do with Ruby. Also TBA. Give him a moment. Give him a moment. Hello. Hey, this is on. All right. Hey, hello. Hey. All right, I'm Zachary Scott. Hey, I'm Zach. And I live in San Francisco, where we are #1 in first world problems. I'm actually originally from Vermont, and I had to put this slide here today. It's negative 26 degrees Celsius. Notice that's not freedom units. I put this in here. Basically, like my talking point for anyone in Europe, like I understand this number, and that's like it. So I work at a company called Shutterfly. My title is Senior Archaeologist. I gave that to myself. And basically, I just work on legacy code there. I'm also I feel like everyone in Berlin has scientist somewhere in the title, so I made. Wait for it. I think I turned it off. Sure. Did I hit it?
No, it was me, sorry.
Oh. We good? Okay. Yeah, so I'm a substitute scientist. I don't actually have a PhD. So take my word at it, I don't know. So they also pay me to work on open source. As you mentioned, I'm a Ruby committer. I'm a Sinatra committer and Rails committer. Some people call this the trifecta. I like to think of it as a triforce. Oh my god, we're in Berlin! I've actually never been here before. I'm really excited to try some real German beer. So I want to, special thanks, I really want to thank Travis for putting me up, giving me an office while I was in Berlin here, and the Berlin Ruby group for getting me here. Basically, I could not be here if it wasn't for them, so please, round of applause. Many parts. So the agenda, yeah, what are we going to talk about, right? I submitted this talk, I really wasn't sure. TBA, really not sure. Basically, to be awesome is my idea. Just kidding. Are also to be announced, so I have a very special announcement. Oh my god, Sinatra 2, it's real? Just kidding. Now I'm going to talk about profiling Rails. So I'm going to show you a Rails app that I worked on for benchmarking Rails, and some of the benchmarks we can use and write them, and how to analyze those results. So let's get right into it. We good? We on fire? Not yet. So I made this Rails app. It's just called Shared App. It's on GitHub, and I'll walk you through basically what I have set up here. It's very simple. But I'd really love to help if you come up with a better name. It's it's a terrible name, right? I'm not a product person. I don't even know what I'm doing. I have it set up. It's just basically a simple CRUD app, and I have it running on different versions of Rails. For example, I target 4.1 stable branch, and I have these dependencies. We'll talk about this one later. But basically, I run, I can gem install, maybe the bundle gem file, this thing, and then bundle install, and it'll give you, from this gem file, it'll use that specifically when, bundle exec, bundle install stuff. So in doing that, I can run rate T, and I can search for these performance tasks that come with that gem. And these are a few of them. For example, the IPS measures the iterations per second that we can call our app. And so in 4.1 stable, we can call the home page 134 times per second. That is the basis of that. Comes with a few other things, like I said, these. We can specify the path to hit, which is the endpoint that we want to test. So you can write Obviously, then if you write any Rails app, you can write any endpoint, or if you have an existing endpoint, so you can give it that and specify what you want to test exactly if you want to do various things against it, like RAM over time, or profile the memory, or run iterations per second. You can profile the GC. I'll talk about how that's actually a terrible thing later. And you can even do the traditional benchmark test, which comes with the standard library. And then you can specify how many times to hit that endpoint. So this is really super useful. Like if you have an existing app, you just install this thing and then give it your endpoint and then test it. And this comes from derailed benchmarks, which Richard Schneeman wrote, and he works at Heroku, and he basically took some code that Aaron Patterson wrote and turned it into a gem for testing rack applications. I just basically have a plain rake file, which Rails will auto-load, and then just require these files and that, and you get the default things that I showed you. The first one then being IPS, which basically looks like this. Calls the IPS in a block and reports callback. The important thing here is it requires setup. This thing comes from the real benchmarks, and basically what it does, like I don't expect you to read all of this, but it separates some things out, and the first thing it does, it calls Rails load if you're using a Rails app, and that basically does all this stuff. It's like very, very large amount of work to basically take your application initialization away from the benchmark so that we can cut out what we are not responsible for, i.e. the web server and initialization, startup time stuff, and get as close to the real thing as possible, like i.e. a running app in production. Also notice here somewhere it specifies production as the, here somewhere in there. Anyways, that's super helpful. Like you can look at that code, or you can even just use this. Like when I write my own custom profiling things for Rails apps, like I inherit that task so that I don't have to think about it. Like it just works. It's very nice. It also has the, like I said, the test using benchmark from the standard library. Very simple, just call out, right? You're going to see a trend here. So GC profile, like as I mentioned, like this comes with core Ruby, and it was in 193, and it profiles a GC and reports it, and then disables GC after reporting. I don't know, that's terrible probably. But it would give you something like this, like invoke time, the size of what was collected and the heap, and the total number of objects, and the time it took to do the GC. This thing is kind of cool because it gives you this hash of these stats, and you can build basically tooling around this and profile your application in various ways. And each of these keys represents something that you could obviously heap, total size, use size, invoke time. Super useful. We really want to know this information when we're profiling, like the garbage collector, when we're profiling applications to see, how many times we're invoking the GC, when we're invoking it, and how much time it's actually taking per request. But I have to warn you, when I did this talk after Falson was the first time I gave this part, and like Koichi was like, hey, by the way, you shouldn't use that. Like, not a good idea. You should be using GC stack instead, which is similar hash and returns a bunch of information about GC. It's more accurate. It has way more keys, way more information. It includes like whole object count. Like if you've heard of anything about the new garbage collector, it has a concept of age. And basically you can have it, it has major GC, minor GC count, a bunch of really useful things that for profiling really is super helpful. There's also this memory profiler thing, which this gem was written by Sam Saffron, and just runs the report by calling your app. And this basically gives us allocated memory for gems, number of objects, by file and location. We can also get that information. We can get retained memory by gem, file, and location. This is using object space underneath the hood, which uses a number of APIs which were introduced in Ruby 2.1 and 2.2. So if you want to take advantage of this stuff, like you should be on the latest Ruby. It also has allocated strings and retained strings, and all the other types. So basically, like in the original version of this thing, wait, no, I didn't show all this space. but it has like objects allocated, classes allocated, all that stuff. And so it'll give you a report of each of those and then how many retain within your block. Oh, that's funny. And then, like I said in IPS, basically the important thing here is call out. So what is call out, right? Basically, it makes a request and calls the method get to path to hit the constant that you set in your environment. But I have to warn you, like this probably isn't ideal situation. Mainly, I think get, you might want to test other endpoints other than get, right? You may want to test a post request or an update. And this bad request thing, and sure, if you want to overwrite this method, it's basically impossible. Because you have to do this in every time you monkey patch if you were to do that. And path to hit, like it would be nice if you could just pass that into call out. Then you can set it yourself, or you can just inherit the one from the environment. Also, it's embedded in this setup task in the gem that you built, which probably isn't ideal because, as far as I know, when it's inlined in a rake task like that, there's no way to actually get at it unless you do some VMX, which would be pretty ugly. But the best place would just be to pull this method out somewhere and just define it once instead of both places. So that's what we have available. I'll talk a little bit about writing some more benchmarks and my experience in doing that. I will warn you, like there's more things to be wary of. For example, I was trying this memory profiler thing, which outputs all that super useful information, and I was trying to benchmark RDoc because when installing Rails, if you actually have documentation installed, it's very slow and can take like 5 minutes or something. This is why everyone puts no doc, no RI in their gem.rc file because they just don't want to wait that long. But I think that's bullshit. I think people should have documentation installed on their systems because you're going to get stuck, you may not have internet, you're going to want that installed, especially for a product as big as Rails. So I tried this out and I ran this test and I was like, this can't go wrong. Like, it's already consuming 14 gigabytes of memory on my 8 GB MacBook Air. And it's like, it's using all of it and then swapping the rest, and it's like, it just keeps growing and growing. And so eventually I just give up, like it used up 30 gigabytes overnight, and I was like, cool story, bro. But basically I talked to Koichi about this, and he's like, what do you, like, I guess I should have just gave him my slides before, because he's like, yeah, memory profiler actually disables GC, that's why it takes so long. I'm like, oh my god, I should have known that before I wrote this talk. But I do now, and I can share my So going on, like I mentioned, you can test endpoints. So I wanted to have a bunch of data to test on this app. So I created like a bunch of articles and a bunch of comments. Like it's a one-to-many relationship. And so I created a bunch of those, and I stuff them full of data, and then I create a ton of comments. And I can run this and like specify using the environment like how many I want to create, how many things I want to test, right? And then return that. And I just have like some checks because I was writing this really fast in place. But for example, I can write this benchmark, which will test like all and all eager. And these endpoints basically I've specified like a lazy loading of all of these comments on one page, and a eager loading of all of them, just to see like how this would actually work. I really want to be like, well, I have a really obviously like performance regression in my app. What would this look like if I was testing it? And like I created these two separate actions, and like obviously this includes it. And then I ran the benchmark, and it's like exactly the performance is almost identical. So I have no idea there. But I heard another good thing to do with Rails is inline your templates, like your partials. If you're, say, rendering 1,000 comments on one page, instead of calling render 1,000 times, you just inline it. Like, for example, when I was looking at the memory profiler, it allocates the string 10,000 times for all the comments I was rendering. Like, this could probably be alleviated if I just inline the comment in my page. So I ran that, and it's exactly the same. I have no idea why. If you can come up with some better examples, or if you have still Rails code, I encourage you to try these and compare the results. There's definitely some analysis that gets involved in this process. Like, I still have no idea, but I guess it's slightly faster, and there's like something like 50,000 comments, so maybe I was doing something wrong. I was also like in a rush, but anyways, the important thing is to recognize, like, when you're writing a micro benchmark, like testing a specific thing versus hitting your entire stack, which is what we're doing when we're testing like the baseline endpoint stuff. And there are certain trade-offs when making these changes, like versus inlining that partial or whatever it is, whatever you're doing. Like, there's going to be certain trade-offs, and we're talking about like making things faster, or taking up more memory and stuff. And it's really this is what your question is, like speed versus space, or like time versus memory, and how fast something is. We should ask ourselves like two questions, like how fast is it and where is time spent. So if we can find something that we think is slow, we should be able to answer these two questions and always measure twice and count once. There's certain hotspots in Rails apps you should look for. We had a discussion recently on Basecamp about improving performance and having longer running benchmarks and stuff, and Andrew White, who works a lot on Rails, had this to say. Basically what he said was URL recognition generation, model instantiation, and lookup and template rendering are basically the slowest parts of Rails, which in my opinion is like all Rails is going to do, right? So don't use Rails, I don't know. Compare all the things, like I showed you, you can benchmark against releases and use different gem files to specify that. Definitely the bundle gem file thing is super useful for that. And you can set up, like if you have a CI, you can set up like in your Travis YAML file, you can specify, like different builds and like pass in environment variables, so you could override like the default gem file and use whichever one. So like a lot of my gems test different versions of Rails or different versions of Ruby that way. Super useful. And definitely like with different ways to integrate patching into that process so that you can get the latest things tested on your machine and in your system. I showed you the gem files that I had, and going further, like there's been a lot of progress in this as that discussion arose. Basecamp, we basically now have Rails Perf, which is a project to periodically run benchmarks on these micro benchmarks on these various parts of Rails, and like we have comparisons of like Rails 3.2, Rails 4.0, 4.1, and 4.2 in active record, and there's some router tests on this site as well. The code is available on GitHub, and you can contribute to this project and run it. And there'll be, if you watch this thing, like there'll be more and more stuff added to it as we start to refine it and add more tests to it. There's also rubybench.org, which is another project that's sponsored. And they're using bare metal machines to run these benchmarks, and they're using like basically Docker to build the binaries and set stuff up. And they're running discourse benches and some other benchmarks that they've set up. This is specifically for Ruby, but this is super useful for people that have Rails apps because it gives you an idea basically what to expect. For example, on this test, we can see discourse homepage, which I don't know if any of you use discourse, but it's basically just a simple product format. And this has been run against all patch levels of Ruby since 2.0, 5.7.6. And they're even testing GitHub, which has a number of performance patches that landed in the GitHub fork of Ruby because they're more willing and able to test those patches than we are as a team. So we have limited resources where we have hundreds of engineers paid full time to make this stuff better. But you can see things are definitely getting better. This is the 90th in green and the 99th percentile in orange. And so it's definitely like between 2.1 and 2.2, it's definitely got better once we've introduced. And this code is available for the Ruby Bench, like the app that's testing this stuff, so you can add more things to it, more tests to it. Basically, that's all the time I have. Thanks so much again. Enjoy the rest of your night.
Thank you very much, Zach. Are there any questions for this talk in particular? No? Okay, well, Matt?
was the difference between the 95th and 99th percentile in like 2, 1, 3, 4, and 5, all GC stuff?
All DC stuff. Let me just calculate that real fast. Really depends.
Big difference. Much
I mean,
bigger than any of the other ones.
So basically, what they did was the mark time has always been the same. Basically we have a mark and sweep garbage collector now, and so what it does is it separates like these two things in a different. Instead of like just stopping the roll and doing it all at once, you can do it like incrementally, right? And so the mark time has always been super slow once we've done that. And the sweep time has basically been larger. And so breaking it up into different generations basically just delays the time. I mean, if you combine it, basically the same, but the pauses are spaced out and so that you don't feel it as much, right? Like it's relative, supposedly. So it should feel faster, but its time is relative. We can talk more about the GC and stuff as well after.
Any other questions? If there are no other questions, since we have Zach here probably only once every year.
Hopefully more than that, I would hope.
Oh, that's great.
Yeah.
Yes, Julian.
Where is GitHub for Ruby for? I'll just Google for
It says github.com/github/Ruby. Yeah.
Super difficult to Google.
Yeah, and I think they make like the default branch is the one they're running in production and stuff. And you can run that yourself. I recommend testing it before because they did innumerable patches that we have not. It's definitely interesting and works pretty good for some people in most cases.
As I was saying, since we got Zach here, I would also welcome, or I think he also welcomes general questions about like how do you become a C Ruby and a Rails committer. I remember it's like from Aaron Pedersen from, I don't know, 3 years ago or something, where he was the only person who was that, so it's actually quite a big accomplishment.
So I'm not actually Rails core.
Oh.
And I don't have DHH in my pocket yet. I don't think anyone does really, but I've been working on it. I've kind of gotten burnt out on Rails just because like you released and now it's like, all right, every time after you release, like you can kind of take a break and refocus on what you want to do. Definitely, if you have any questions about contributing to Rails or Ruby, definitely approach me. I can help you. I've helped a number of people, mentored people, get their patches in and stuff, and that's kind of what I like to do is talk to people and help them contribute, because I had people that basically took me under their wing and mentored me in open source, and I want to be able to basically give that back to people, right?
Yes, I got 3 grids on Ruby, and Zach merged all of them. They're all just documentation, but Zach helped me with all of them. So.
I think it's a question.
Oh yeah? Question? Got whoa back there.
Run! How do you become Sinatra core?
Rails, non-Ruby stuff.
Can you say that again?
Yeah, what non-Rails or non-Ruby stuff are you on?
Non-Rails, non-Ruby?
Yeah.
Does mRuby count?
Is there something
Sinatra? No, I don't know. I mean, I really love Ruby and C. Like, I have a hard time switching to anything else. I get pretty bored fast. I end up going back. It's also, the community is awesome. Like, super good community. You guys have an amazing meetup. Like, I'm super happy to be here. I wish the night would go on forever.
The night goes on as long as you like the afternoons.
I have one other question. Someone asked how to become Sinatra core. And the answer to that is basically go to MagmaConf in Mexico in June and just buy him enough tequila. That's how you get it. It was literally like I got an email at like 1:30 a.m. and I was like, what? It was like before my talk, I was still writing it. It was like, you now have access to Sinatra. And I was like, he was serious? You must be desperate.
How is Sinatra 2 coming along?
We'll have an announcement shortly.
We will.
A weird one.
Okay, any other questions? Well then, thank you so much, Zach.
Thank you.